Welcome, guys. Today, welcome for this session. We'll talking about Rook operator, storage for Kubernetes. And I'm Parth Arora. I work for the Rook development and maintaining it. And I work as a part of IBM Storage. Next to you.
Yeah, hello guys. I am Yati Padia. I am a software developer at IBM. I work I work with the Ceph CSI team for Open Ceph Data Foundation thing. So yeah, that's about me. Shubham.
Hi everyone. Thanks for attending this talk. I'm Subham Rai. I'm one of maintainer of Rook, and I also work with IBM.
Hello everyone, myself Deepika Upadhyay. I am a contributor to Rook and also help people with consulting and projects associated with Rook at Clyso GmbH.
So yeah, get you started. So here's the agenda on the topics what we would be talking about. We'll be talking about the Rook Ceph, like what features it's provide and what platforms you can use Rook Ceph. And if you're deploying, what topologies would be good set for you. And if you have already deployed, what would be the maintenance best practices for this. And plus what support we can provide to you as a community. And exciting for the new features that we have developed in the last release. And we have an upcoming release this month only, so we'll be talking about that. And last, like everyone in 2024 is talking about disaster, so we'll be covering that part also. So a quick idea for the audience. Wanted to know, like anyone, like how's the attendance here? So raise your hand if you are like very new about Rook. Okay, I see a lot of session. Nice. Sure.
Nice.
Anyone has experience with Ceph before? Okay, great number of hands. And anyone has deployed Rook in production or experimented with it? Oh, that's great. So yeah, I guess would be a cool discussion on that. So intro to Rook. So back in the history, like when Rook was developed around 7-8 years back, so we were thinking about like what storage should look like. And storage is mostly like we are plugging our external stuff into our environment in our Kubernetes cluster. But why it should be always external? Why it cannot reside in our own data center? And why it should not work like how our other K8s application are working? Why cannot we manage the Kubernetes storage by ourselves in our own cluster? Why it should be always external to cloud providers? So that was the start of that. And we don't want to build a data platform. We want to trust something that was already enterprise ready. And as the data layer is very important. So we bet on Ceph at that time. And why we choose Ceph? Because Ceph is a distributed software storage solution. It like very well works how the Kubernetes architecture work. And as a platform, it provides like 3 types of storage at the same time. The RBD as a block storage, mostly for read-write once volumes, and the CephFS for a shared file system, like read-write many access, and also the RGW, the object storage. Mostly like we talk about S3, so it mostly resembles with that APIs that S3 provides to us. And Ceph is an open source community, and we have big customers like Sun, which have like terabytes and terabytes of storage and petabytes there. And it's designed for its scalability, so that's why Ceph. And talking about like how durable Ceph is, so Ceph is designed for consistency, and not like other platforms like that are eventually consistent. So if you are storing something in Ceph and it's egged, so you're good. The data would be like stored perfectly there. And how Ceph actually makes the inner layer is like it shards the data into different AGs. And you can have replication between different available zones that you have. So like the data coming will go to multiple zones at the same time, and it will be replicated internally. So like let's say if some data has been like there is some impact or disaster, the data will be still be secured. So it's more talk about how data resilient it is. So that's on that. And even in an extreme disaster, you can recover it manually. And also there is a second replication way we can use, that is the erasure coding, that is 2:1, mostly used with object storage. So that's on Ceph. I see like many hands, they already know how Ceph is. So Ceph, directly installing Ceph is a very pain point. So what Rook does is like Rook actually automates its configuration and manage the state of Ceph. And we just provide some simple CRDs. Just go ahead and deploy them, and it will actually launch the Ceph cluster, and it will actually bring your Ceph cluster to the Kubernetes world. And Rook is actually open source, Apache 2.0 licensed, and it automates the deployment, configurations, and also keeps your data safe while upgrades. And with Rook, you can use like the storage like any other storage provider. Like it will give you the storage classes, and on top of that, you can create PVs and PVCs. So this is the architecture layer, how the whole product look like, the whole stack. Rook is actually the deployment layer that's managing the Ceph, its state management of it, and have different controllers to manage the other applications what Ceph has. We have CSI, which is used for the provisioning and the mounting. There are further slides for CSI, and Ceph being the data layer. So this whole stack is like open source, so that's generally available for everyone. So the basic question, how we can install Rook, we have two ways. Someone likes Helm chart, so that's also available, and direct manifest installation is also available. And a quick start guide, you can go to the following docs. And where Rook can be installed, so anywhere Kubernetes that can run, we can use Rook. That can be any cloud environment, any like bare metal clusters. And we have also tested Rook with some of loopback devices that are like storage under the nodes, so that the Rook also works very well with that. And this was a question like mostly asked yesterday on the booth. If I have a cloud storage, why I should deploy Rook on top of that? So there are some limitations that cloud provider has, like there is no AZ support there, and the PVCs are very limited per node. Like I guess there are around 32 we can have. And the last is like if we have hundreds of small PVs and large PVs, then the performance impact is there in small PVs. So what if you bring this Ceph onto your storage stack on top of Kubernetes? You can have a AZ supports, you can have multiple zones and racks, and like virtually there is no limit on PVs per node. You can have unlimited PVs installed, and the performance wise there will be no impact on if you have large PVs or small PVs, because how Ceph is scalable, it will give the performance and keep its performance for time. Plus, nowadays we talk about hybrid storage. Everyone wants different kind of storage at the same time. So Rook is consistent between different storage providers. You can make use of other different storage providers at the same time with Rook. And this was the second asked question in the booth yesterday. Like, you are saying like we should deploy Rook on the nodes where our application is running. What if my application goes or runs out of the configurations like request and limits? So there are three different ways you can install Rook. The first is like the hyperconverge, where we'll give like you can install the Rook on the same nodes where your application is running. So you can set the limits for the particular Rook pods. So depending on that limits only, you can the Rook will utilize its resources. Plus, if you clearly don't want your application to be coincided with the storage pods, then you can have the dedicated storage nodes. Simply, you have to taint some nodes with some tolerations, and the resources will be deployed on the separate section of the nodes. The third way is external Ceph. In the community, the Ceph was from like around 14 years, and some people have Ceph standalone. And if they want to bring that Ceph to Kubernetes world, that's already deployed, we can use of external Ceph cluster. So this is the actual design of that. Like you have external Ceph cluster, and Rook will run as a Kubernetes cluster, and this can extract the external Ceph cluster running using scraping, and it will scrape some data and give a connection to your external Ceph. This is the third way. And the benefits that we have is this, like we can run multiple Kubernetes cluster and connect to just one Ceph cluster. And sometimes some people want isolation, so we can get the isolation for the storage to the Rook Kubernetes cluster separately with this. So next on the Ceph CSI driver, Yati.
Yeah, sure. So talking about Ceph CSI, Ceph CSI is a CSI driver for Ceph storage, which allows the container orchestrators to use Ceph as a storage backend for their containerized applications. So thereby acting as a bridge between the CSI-enabled container orchestrators and the storage backend, which here is Ceph. So Ceph CSI architecture follows the standard CSI architecture with a container orchestrator sending the CSI API calls to the Ceph CSI driver, which then translates the calls into the commands that the Ceph can understand and thereby performing the operations. So it is basically a gRPC server which is written in Golang, which is used to implement the CSI specification. And we have the following different type of drivers. As Parth mentioned in earlier slides, we have different formats, like for block mode, we have RBD driver. For the file system, we have CephFS driver. And for network file system, we have this NFS driver that we have. So this is basic. And next, let's look into the standard like deployment of how CSI is deployed. It's like similar to other container orchestrators. Like we have two different two different pods here. Like one is the Ceph CSI provisioner deployment, and the other is the node plugin. Ceph CSI provisioner deployment usually take care of the volume or snapshot creation, deletion, expansion, and other other such operations. And we usually have two provisioner pods with a leader election functionality, where one of the pod takes the charge, and if in case there is any network issues or like the pod is down, in that case the other pod can take the charge. And so this pod deployment is nothing but the set of containers. Like you can see, we have CSI add-on sidecar container, the provisioner, the resizer, attacher, snapshotter, and the CSI plugin containers, with each one with its own functionality. Like CSI add-ons we'll discuss on later slides. It has volume replication thing, features, network fencing for reclaiming the volume and other stuffs, and like snapshot, CSI snapshotter we use for like creation and deletion of snapshots, so etc. So all these have their own use case. Similarly, we have the node plugin daemon set, which is used for volume mounting and unmounting to the pods, and it is deployed one per node. So yeah, that is about this. And talking about the functionalities and features that it has, it is thinly provisioned, that is the volume is measurable and it can be expanded further. And it has different modes, like as mentioned in earlier slides, the RBD, CephFS, and NFS things. And it is also a topology aware, that is, it can read the OSD from its nearest clients. It allows taking snapshot and clones. And recently, when the group volume snapshot feature is introduced, I think you will be able to see in upcoming release, where we can take group snapshots at a time. So yeah, these are the things. Coming to CSI add-ons. So CSI add-ons host the extension to the CSI specification that provides advanced storage operations, like as mentioned, network fencing and reclaim space, volume replication features, and volume group replication, etc. So we have this CSI add-on controller, the sidecar, which resides in the CSI driver pod, and how the communication takes place. Like if there is any feature, like if you want to reclaim the space or network fencing, there is a CR that is created by the user, which the controllers, which is then passed on to the controller, and the controller passes the call to the CSI add-on sidecar, which resides in the CSI driver through a gRPC call, and then the driver, the CSI sidecar sends another gRPC request to the controller or node plugin to execute the operations. So talking in just a little bit of each of these features. Reclaim space. Reclaim space is the operation that executes the sparsify command on the images and fstream on the file system mode. So to reclaim this unused space, so this enables the storage admins to have accurate idea on what is the storage consumption and in the cluster, so that they can reclaim their space later on, which is not required. Coming on to network fencing, it provides the API for blocking the list of IP ranges. This is mostly for the node loss kind of scenarios where for some situation the node is lost. So in that case, we can pass using the command we have Ceph OSD block list, and we can pass the IP range, IP which we want to block list, and so that the watcher then can watcher will be free to mount the RBD image to the new node. That is about network fencing. Then coming to volume replication, it is another operation which provides the reusable APIs for disaster recovery process, which is now on very much talk. So earlier we had a separate volume replication operator itself, which was doing the disaster recovery thing. But after the introduction of CSI add-ons, we found it very easier to include it as a feature here rather than having a separate sidecar and operator. So that's how we'll discuss on the later sites when we are discussing. Then again, we have encryption key rotation, where earlier what was happening is for each for each encrypted volume, we had a single key throughout the lifetime of the volume or image. So, but now we have enabled the encryption key rotation, where the key is getting rotated with every interval, either by using the feature of annotation of by annotating the PVs and the storage class. So that's how this is work. And RBD mirroring will be covering in next slides. Next slide. So here it is. So talking about the Rook application for disaster recovery, RBD mirroring is an asynchronous replication of RBD image between the multiple clusters. It is either journal based or snapshot based. You can read more about what is the difference between journal based and snapshot based in the Rook documentation. It is clearly mentioned there. We do have how it processes is, we do have RBD mirroring CRDs, where when we create this Ceph RBD mirror CRD, it creates an RBD mirror daemon in the provisioner and in the cluster, and that mirror daemon take care of enabling and disabling the replication, so that we can process the disaster recovery thing. And for carrying out the particular events, we have volume replication CRDs, where we create the volume replication class and volume replication CRs. So you must be aware of PVCs and storage class. So it is similarly, we have this volume replication class, which is similar to the storage class that we create, and volume replication is similar to the PVCs that we create. So this we have volume replication class, which extends the APIs for the storage disaster recovery. We have volume replication, which is created per image. For one PV, we'll have one volume replication, and it will take care of promoting, demoting, or performing rsync operations for particular image, whatever we want to operate on. If there is any failover case where there is one of the cluster is down or one of the data center is down, then in that case, the volume replication will demote that particular image and promote the other one on the secondary cluster, where you can just access this particular image which was down here, and hence reducing the time for retention. So this is the whole of the process that we do for, and this is particularly for the block mode. Similarly, we have Ceph file system mirroring process as well. It is also a synchronous replication of snapshot for the remote Ceph FS file system. It does not have this volume replication and the CRs thing, which is not automated actually currently, but you can check out, we can manually configure the peers, the snapshot schedules and the retentions thing. So in the backend, so the details of how we do is mentioned in the Rook documentation. Please, if you want, you can go through it. And the daemon that we had in RBD, it also creates Ceph file system mirror CRD. We do create, and it creates the CephFS mirror daemon for the process. And currently it is experimental, so we don't guarantee anything. So like you can always feel free to test it out. You have it in Rook documentation, so you can also try it out and add your feedbacks there. So yeah, this is pretty much about disaster recovery, and I'll just hand over to Deepika for further.
Hello. Now you have seen about how block storage works and Ceph, file system storage works for Ceph. Now a big use case for, I think, Kubernetes world is also just object storage. So how does object storage is provided by Rook? So currently there are two ways to provide object storage. The first one, container object storage interface. It's right now in experimental phase. It's Kubernetes suggested way forward to provision object storage. But what we currently use is object bucket claim. Now, how it works is similar to how the block storage and file storage works for Rook. What it does is it creates a bucket, an S3 bucket, and then gives you access to that bucket using Kubernetes secrets. So a bit more on that. As you see, the Rook architecture, maybe we focus on the orange side of the diagram. You have an app, and you want that app to use the S3 client, and it should be compliant with the S3 API. So you just ask Rook to create an object bucket claim. It creates a RGW bucket for you. RGW is what is providing you the bucket from Ceph side, and these credentials you can access through config map and also the Kubernetes secret. And once the bucket is provisioned, you have your access credentials in Kubernetes resources. You can get started on using your app or just using S3 CLI or on from anywhere. So that's how it works for Rook. And coming to observability part of Rook, we also have Prometheus and Grafana integrated with Ceph. And currently for Rook, we are using these dashboards for providing us the metrics associated to how the data is, where the data is. You can monitor the cluster status, see how many hosts are there, and check for what if there is any failures. Prometheus alerts are integrated as well, capacity, the number of object stores, and also the client throughput and other real-time metrics. Apart from these, this is the second overview, which is again not the integrated one, but this is a general Grafana dashboard that you can use externally as well. These all resources are available in Rook documentation, and you can just get started with observability in Rook as well. Then for cluster maintenance, now the big question is, if I'm doing an upgrade, is Rook reliable in that particular side of things? So how it works is, if you take down node, all nodes can be taken down in one entire failure zone with no downtime, and all data remains available for both read and write. What that means is it can the read and write would go to the other availability zones, and can continue. The availability would not be hampered and can continue on even when the upgrades is going on for another availability zone. And how the upgrades work is, we have something called pod disruption budget that somehow ensures that that whenever we bring down a node for maintenance, that the other copies are not hampered. If we are instructing Ceph to maintain 3 copies at a time, then Rook would take care of the part that only one node or one copy specific node goes down at a time, so you still have availability for those 2 other copies. Now, the same is said by the other point. Rook upgrades ensure that one failure domain is affected. So essentially, no downtime, no hindrance to like data loss, I'd say. And if a cluster goes down, not that we have seen it often, but if a cluster goes down, your data is still safe as long as there's one failure domain available. So you still have 2 copies, or you lost 2 nodes with those copies. Yeah, so if even one copy is available somewhere, we can get the cluster up and running and heal the data itself in the background as well. Then how do you, now you know you can store your data reliably. Do you want to measure the performance for the cluster? This slide covers the tools that you can use to measure the performance of the cluster. I'll not go into it in much detail because we are short on time. Now I want to pass through Shubham.
I think I'm short on time, thanks to them. So I'll try to make it quick. So in Rook, we do have a kubectl plugin that is based on Kubernetes crew plugin. So for Rook, what it does is, it is basically built for troubleshooting. And initially, I saw some of the attendees here already use Ceph. So to give some example, what this kubectl plugin does in Rook is, it used to run Ceph commands, it used to restore mon quorum, and you can go through this in details in Rook doc. We do have a great doc. This crew plugin helps in removing bad OSDs, running some mons and OSD maintenance operations, and it also helps in restoring the CRDs that are accidentally in deleting state. And we will also love to get some feedback on what other scenarios you will like to get automated with this plugin. So happy to get some feedback. And I will quickly go through the Rook project updates. So initially, Parth mentioned that we are open source and community is important to us. We do have a monthly community meeting, and Rook is based on Apache 2.0. And we have a major contribution from 4 companies: Clyso, Cyberzoo, IBM, Red and Abound. And we have slightly updated. We have more than 500 contributors to GitHub projects and 340 million container downloads. And Rook is CNCF graduate project. Rook got in Sandbox in January 18, incubation in September 2018, and graduated in 2020. So you can see with this short timeline, Rook got graduated. It means that Rook is really stable and good for production use. And for Rook, stability is #1 focus. And it is more than 6 years. Rook is declared stable and ready for production. We have many upstream users using Rook in production, and same goes for downstreams or more customer-related deployments. And Rook runs on any commodity hardware. Release cycle, we try to release every 4 cycle, and our last release was 1.15 in August, and we are planning 1.16 in December. And we do have a bi-weekly patch release if there's something we need to fix. So we do have a bi-weekly releases, project updates. So I will not go in details since I think we are almost over the time. You can look at these slides later. Just to quickly mention few, in 1.15 we added support for Ceph Squid, and yeah, we also added support for CSI operator alpha v1, which is in alpha v1 state, and we removed the holder pod for multis networking. And in 1.16, our main overall theme will be supporting users with complex need, like disaster recovery, and it will be more S3 focus release, I'll say, and we will also remove support for Ceph Quincy. Rook tried to support at least 2 latest Ceph releases, so yeah. So yeah, thank you, and these are the details you can check out. And some appendix you can look later.
Any questions you guys have? Yeah. Yeah.
Yeah, hello. So I have a question for CSI team. Like I see that you have 3 drivers. Why not have a single driver catering to different storages?
Yeah, we are on it.
Oh, you are already on.
Yeah.
But
It will be soon released. Like we are coming up with a separate CSI operator, which will have all in one. So yeah.
can you
there were-
discuss the reasoning behind like shifting from one strategy
So
to another?
earlier we were facing some security issues, and it was designed in that way. Like we had like it was upcoming, and like different modes were supported. But now after like all the like testing and everything, like we found that it is more like stable, and we will be able to use it in productions and everything. So we are coming up. Almost it is ready. I think we'll have it in next release.
Yeah, good. Thank you.
Thank you.
Like basically we went over, I think one of the slides that like if the entire AZ is down, kind of, so is it the default replication factor of 3, or like how is the replication?
Sure. Yeah, the question is how, if one of the AZs is down, then how we can get rid of like that downtime and still get the data available. So generally we have 3 replication vector, and so the data that is coming is replicated to 3 of the nodes. So at least if one of the zone is available, we can still recover from that data. And there is a second mode that is erasure coded mode. That is like 2:1. We will store 2 like data in 2 nodes, and one would be the key to the hash key to recover the data. So like in these both ways, we can have that replication done.
Okay, so just to kind of follow up on that, like okay, if one of the AZs or one of the nodes is not available and there was some data there, would it asynchronously replicate into another node to ensure eventually you'll still have 3 replications?
Sure.
It will also depends on the failure domain you have. You can either have failure domain of node or OSDs or something. So let's say, for example, you have a node as a failure domain and one node goes down. You can plug in another node in the same AZ and then add the disk or the OSDs, and your data will be.
It will automatically discover that new node and proceed the data from that failure node to the third node.
The replication factor like if you want
Yeah.
4 or 5 or
Yeah.
Yeah, you can do that. Based on the nodes and the architecture you are planning, you can play with that.
One question.
Yeah.
Actually, this is regarding the CFFS performance I was playing around
Okay.
with. And I struggle with the default strategy of how you file striped across these nodes, right? The default strategy is not good. It is very well documented. It's a simple strategy. It's object size is equal to the, the block stripe unit, and stripe count is 1. So that is not good. So I tried modifying the stripe count, but the result was not coming out very good, after the striping was not behaving the way it should be, the way it is documented, right? So have you also faced this kind of problem? You tried changing the file counts, the file striping strategy?
Generally, the native configurations works very well. And if you have certain changing issues, we can, like, as it's an open source, you can open a request for us, and we can take those to the community, the Ceph community.
Because I tried fiddling around with all these parameters where I changed the, stripe count, changed the object sets and all that, but the result was not coming out to be very good. It was not performing very well.
Sure, we can take that offline in the booth.
okay.
Yeah.
Sure,
Thank you.
thanks.
Depends on your configuration or sometimes hardware also.
No. So hardware-wise, because we were comparing with other storages, so other storage was
Okay.
performing pretty well. It was NVMe SSDs and all that, so it was pretty well. So from hardware side, it wasn't a problem. But the way it is documented in Ceph also, it is very clearly mentioned the default strategy for stripe, file striping is very simple. It is not optimal. So you need to fiddle it around. You have to change it.
Okay.
So I tried it, but the performance wasn't coming to be good out.
Got it.
Out of
Yeah, we'll
stretch,
take care of
yeah,
that.
sure.
Anyone else? Yeah. Can you pass the mic?
So one question. This is regarding multi-tenancy. So for if we are using some external storage and that is a central site for multiple Kubernetes cluster. So how do you make sure that multi-tenancy would be provided for Ceph CSI, Ceph FS?
Sure. So actually we have this external mode I talked about where the Ceph is running in the external mode. And so we actually give the permissions to one of the Kubernetes cluster in a reduced form. Like whatever it's important for that tenant, we just give those types of permission to that tenant. And if the data is coming through that one tenant, it will store securely in particular logical namespaces like Rados namespace and other things. So that makes the feel like it's totally isolated between the tenants.
So is it like you create a separate file system for every cluster, or
So we have
can use
another logical layer that is sub-volume group. So on top of file system, we can logically divide that file system between these sub-volume groups.
actually I was working on that, and at sub volume level, it was like at Ceph level for particular file system. So every client, every every Kubernetes cluster can access the data at sub volume level. So
We actually have the reduced Ceph users. I can talk to you that offline. We actually reduce those permissions per tenant only.
okay.
Yep.
Thank you.
Yeah. Can you pass the mic?
I have one question. Is there a way you are handling that small files in the storage?
Sorry,
Like
can you
small
please pardon?
files, small file. Sometimes we have lots of small files, so we have to compact those files into one file. So is there a way you can handling that thing? So while
I actually didn't get. Anyone else? Small files into?
storage, suppose we are in S3, so we are keeping lots of files. The size is very small, so
Okay.
we have to do compaction.
Sure.
So is there a way Rook is handling that part?
That's Ceph side of things,
Yeah.
and I think we do compact data, but not directly. Like we are not zipping it somewhere or compressing it by ourselves. But if you want to store the data, you can. For small files, I think RGW or the object storage, maybe S3 bucket would be a good use case for you. But maybe, I'll take this feedback and get to the community.
Yeah.
We are not storing that small files. We are getting a small files. So after that, after a few times, we have to compact those files to a larger file to process.
So we generally for small files, I have seen in KB sizes, I've seen bucket people using S3 bucket for storing such files. And maybe bucket could be the logical volume that's more suited for small files
Yeah.
in your use case. But if you want to access those files, then also you have to uncompress and find where it's stored. So I don't think so. It's currently doing you can maybe do the compression part at your side.
Not compression, compaction. Yeah.
Okay.
Basically,
We can discuss this offline.
Yeah,
maybe
sure.
it could
Sure.
be a good
The interest of
Yeah.
Okay,
Thanks for that feedback. Yeah.
Okay, I'll go. Thanks.
Sure.
Yeah, so in your initial slide, right, you mentioned about the CSI, the Ceph CSI add-ons and all, right? And you specifically mentioned about the encryption key rotation.
Sure.
So my question is, how do you manage the encryption? Do you manage the encryption natively, like the Rook Ceph support natively, or do you rely on, let's say, AWS KMS for key rotations?
Actually, we use KMS and other storage, Azure and other platforms for that, and Vault. And we actually use the key rotation for the key that is being used, and the data is not re-encrypted. It's the key that is being changed in some time. So once they rotate it, the only new key can access that.
Okay.
And we have a kept procedure for like properly.
Understand, there is nothing native, right, right. So you're encrypting the storage in REST, right? The data in REST, right? You're encrypting it.
Yeah, it's available. Compression in REST, yeah. That we have like MON endpoints, that's encryption in REST that we have.
Thank you, yeah.
Yeah, thanks for the wonderful session. So I just have a couple of queries. So first is when you mentioned about the CSI agents that are being deployed, right? So just a query on that. So when you meant the daemon set, like the specific plugin for accessing like mounting or unmounting, so that means the CSI driver should also be on the nodes where your application is also running?
Yes.
Okay.
That's
And
correct.
okay, and the second query, this is related to the disaster recovery, right? Like typically whenever we have a node down in our Ceph ecosystem, or see even when an OSD becomes down, right? So that is when your rewait kicks in. So during your rewait, you basically have your back calculation and all those things, and that is typically Ceph tracks it. You will be able to see the recovery rate that is there, but Rook, you will not be able to track it through Rook, right? So if I may,
You can track it, like I think I used, so if you see there's monitoring and you can see the cluster health from here and track the backfill, like recovery process, there's a dashboard for it as well. And at what rate the recovery is happening, you can see that as well. And the other alternative is you can use kubectl plugin to run Ceph commands, like Ceph health detail will give you the Ceph, or Ceph status can give you how much backfill PGs are there. And the third one is like there's toolbox bot. So whatever your Ceph commands you run natively, all the commands could be run by the toolbox
Plus,
bot.
Rook has this Prometheus service configured that Ceph provides, and we can log into that dashboard, and that would be like the Ceph dashboard visible to you, and you can look
that
into
is
that
the
processes.
observability spectrum, right? Like what I'm saying is sometimes we faced issues where due to the backfilling, if I'm doing some kind of an IO during that point in time, the Rook operation goes through, but at the end of the day, if I go back to my Ceph RBD or to the Ceph file system, the file is unavailable. It basically, the file gets created, but the contents are not even there.
So you are able to access with Rook and not with Ceph. Is that your
No,
point?
like the application can only talk with Rook, right? At the end of the day, the application that gets deployed, it can only talk with Rook to basically access your Ceph file system. So if my application tries to write, right, the application's write command, the F write or whatever you do, it basically comes back as success, because at the end of the day, whatever goes via the CSI driver, it only gets that result back. But the actual content may not be written onto the file system itself. So that due to some network latency, or sometimes we've observed this because when there is during a backfill,
Which
right?
version of Rook you were using?
No, I think it's an older version, most
So
probably,
maybe
because since it's in a
we
production
haven't
setup,
seen,
right? So yeah.
Like this issue recently.
Yeah, so maybe in offline we can just
You can
discuss in
open a
detail. Like
specific
I can
GitHub
just
issue for that, and we can
check
try
with you guys on that. Yeah.
Rook or CSI, like based on that, we can open the issue.
I wanted to understand your Ceph NFS use case, because you're already offering Ceph FS as RWX. So what is the exact use case for Ceph NFS? What are you offering in that?
We have that network file system support with that.
Yeah, but the point is generally people are using for
NFS
RWX.
Ganesha thing, like I'm not we are not working on deeply on NFS side, but whatever like on surface level we know is we do have NFS Ganesha, which is which is supported by this NFS driver. So I think there are very few cases a particular use case for that.
Yeah, I know, but generally people are using this for sharing data across nodes. So you already have Ceph FS as an offering there, which offers you RWX access mode, right?
Yes,
so
yes.
what actually this brings on table, when you compare it with Ceph FS, to be honest?
Actually, Blaine Gardner from our team is working on that. So
Yeah,
he's not here today. But yeah, we can.
I mean, it's up to you. Like, do you want to use NFS? Then there's support for it as well. Of course, by default, Ceph is more supportive towards Ceph FS. But we also have NFS Ganesha in Ceph natively, and that's also extended.
Mostly
to
provides some advanced features on top of what Ceph FS provides, like sharing with, like even one file,
So,
maybe like to the environment, sharing and accessing at the same time. What's native NFS is.
Yeah, because with CephFS you have a possibility where your IOs can go from different nodes together, and it's a CephFS which is managing that, right? Because if you have an NFS running, ultimately all your IOs would land up on your NFS service anyway.
Right.
Right. So that, and your NFS is not scalable. What I would say, right? You are you putting NFS as a scalable?
So yeah, it goes with the CSI driver itself.
Yeah. Okay.
It actually, it's connected with the CSI driver that we have, and it actually works how our native CephFS works.
That's actually the basic.
So we have, for CephFS, we have MDS pods that MDS server runs.
Yes.
And for NFS, we have the NFS server pods that runs. And it actually goes through the CSI layer.
Yeah, but I was really, wanted to really understand your sharing is anyway can be achieved with your CephFS anyway, right? So what this would bring at what extra benefits you would get by using NFS with your CES?
Okay.
Yeah, that is something which we'll like to
get that.
Yeah,
sure.
please, thanks.
Offline.
Maybe we can connect our Slack.
Can you pass it at the back?
It is also there in Ceph documentation.
Yeah, I'll have a look at it. Yeah, thanks.
Sure.
Yeah.
Yeah.
Sorry, I'm a little new to this, both Rook and Ceph. So I wanted to understand, let's say there is some issue with, if the OSD has gone down or there's some disk corruption that has happened on Ceph, does Rook have the capability, I'm just asking from an observability perspective, does Rook have the capability to run a deep scrub or something and then collect the logs and keep it ready before any disaster recovery happens?
Sure. So Ceph is very self-resilient, I would say, and it's an operator, and we have written controllers over that. So it actually, if there is some error, it actually resolves the error by itself by reconciling the operator. And if it's stuck somewhere, we have logs and log store at the host path. So through that, we can actually access the logs once even the cluster is gone or something like that.
So we were not able to cover troubleshooting here, but if something is failing somewhere, Ceph is aware of that failure and marks it out that this is not part of cluster now. Make a new copy of it somewhere, and when the copy is made, it will scan for there's a operation for deep scrubbing, and also when if something is lost, then backfilling is an operation that will take care of creating the new copy that went down from the two existing copies that we already have, just to make things simpler. So this is an operation at Ceph layer. Rook is just an operator that's helping Ceph to manage storage in Kubernetes world. And Ceph has been doing it for 14 plus years and big clusters, so should be good.
Okay, just one more question. So on a single Kubernetes cluster, let's say a number of multiples of 3 nodes, since Ceph recommends 3, is it possible to have multiple Ceph, one Rook operator can manage multiple Ceph clusters?
Yes,
it can do that.
There is a way for installing multiple Ceph cluster. We have a quick example to do that. We can have multiple Ceph cluster just on a different namespace.
Different names.
Yeah.
Okay, cool. Thank you.
हिंदी में बात कर सकते हैं. सेफ जो है स्टोरेज के लिए यूज़ क्या कर रहा है? जो एक्चुअल स्टोरेज ले रहा है वो एफएमएल स्टोरेज है जो कुबरनेटिस क्लस्टर के नोड्स की होती है, या फिर वो स्टोरेज ईबीएस से मान लेते हैं AWS में वो ईबीएस से पावर्ड होगी. तो सेफ कहाँ पे है? कौन सी स्टोरेज मैनेज कर रहा है सेफ? रुक सेफ को मैनेज कर रहा है, लेकिन सेफ क्या मैनेज कर रहा है? क्या स्टोरेज है?
बेयर मेटल, EBS, किसी से भी कनेक्ट हो सकता है वो आखिरी में जाके. Ceph,
I see.
That's why it's hybrid. It can be with Azure, it can be GCP, it can be bare metal in your own cluster. And the Ceph has so many features as we talk about, like disaster recovery, replication, and different types of storage we are getting out of that, like the block, file, and object at the same time.
So effectively, फिर Ceph का purpose क्या रहेगा? कि अगर मेरा क्या बोलते हैं जो underlying storage है वो ही मैं EBS यूज़ करने लग जाऊँगा, या फिर EFS यूज़ करने लग जाऊँगा, या फिर S3 यूज़ करने लग जाऊँगा, तो फिर Ceph का purpose क्या रहेगा?
So for this you are bringing that external thing to your own cloud. That's one of the purpose. You are maintaining that, you are securing how you are managing your storage, and actually if you have to get that S3, you have to pay something extra. Here you just need SSDs or SSDs, and you can plug and play directly with Rook.
It's completely open source stack, and you can just bring, create your servers and attach hard disk to it, and just be sure that the data would be fault tolerant.
It's more
and
about if you have big cluster and you are a big user, and some cloud providers at some point of time, there are some limitations with that, and that actually it solves it. So mostly we have users where the performance is the key and they have very, very big and large clusters.
Okay.
Yep. Yeah, you can go after that.
Yeah. See, as a user, if I am only interested in object storage, so Ceph as an object storage, and let's say MinIO also have an object storage. Like, if I want only object storage from Ceph, is that possible to bring down the cluster of the Ceph where only MinIO
that's
can?
totally possible.
Yeah, so there's an option. You can just completely disable CSI for RBD and CephFS. Then your Ceph cluster becomes just for object storage use case. We have people using it that way as well, just for S3.
So would the size of Ceph cluster itself reduce?
Yeah, so in the diagram, if you see, like, there's RBD.
Last one. It's
too far. So one more.
This one.
I think after this. Yeah, so in the diagram, these units would be available, the OSTs would be available, manager and monitor. So MDS will go away. This is for the file system, and the RBD, like CSI and CephFS CSI, these goes away, just S3 and these units. But these units are actually the hard disks, and this is the gateway for connecting to those hard disks some way. So your cluster reduces to this.
Okay, thank you. So there is a documentation to do this.
Sure. There is a simple configuration spec that you can use for that.
Yeah.
Okay, thank you.
Yeah.
Benchmark your
Yeah, so you can use the standard ones, like we have our own tool as well, Redos Bench, HS Bench, in-house developed, and then we have, I forgot FIO workload you can run, and then WAP as well. You can use that for S3 benchmarking. Actually you are benchmarking the Ceph cluster, so that's completely documented, and if you need any help, community is always there. So yeah, I think I was not able to cover it, but you can have different use cases as well, threads, multiple clients and all. So
so in Ceph internal mode, in case we have different sizes of disk and different number of disk, how can via Rook we can get
So we have a feature that is called a device class, but actually is like separates your configurations or OSDs separately using that device class label. So you can have certain sets of OSDs with certain device class and connected to the application, and certain big size of OSDs at certain levels. And even you can label the different size of OSDs with same label, but the thing is you have to balance out between the nodes that you have. Like if you have 3 big and 3 small, you should balance that, and it should be totally fine for the cluster.
The answer is basically creating multiple storage device
class. Yeah.
Okay, thank you.
Do you have some general advice or best practices for deploying Ceph Rook on premises, primarily on smaller Kubernetes clusters? Right. So typically in our production, we deploy it in our customer's environment, and these are generally VMware data centers. And most of these clusters are 3-node clusters. Now we install Ceph primarily for the RWX capabilities, right? Do you have some general advice for smaller Kubernetes clusters? Because we do see issues like when all 3 nodes go down, for example, there's a power outage in the customer network, we actually struggle to bring Ceph back up because the OSDs just refuse to connect when all the 3 nodes go down and they're back up after the reboot, right? So I'm just wondering if there's something basic hygiene that we should be doing when deploying on premises.
Basically, the examples that we have in the YAMLs are perfectly set for those only, like the best practices. But if you really want, you can configure the OSDs with different zones. So that kind of hierarchy would help you in recovering. Like you are saying, like if you are having the same nodes, they can go down at the same time, but you can change the failure domains at time and try with that.
So each OSD needs to be in its own failure domain, I think.
Exactly.
Yeah, wherever like you see 3 nodes failing, you should have like a copy in somewhere else. So if the failure domain is nodes and all 3 goes down, that means we are virtually having no copies available. So Ceph gets confused. Oh, where to recover from? So you have to make sure that you have like if something is going down in one area, there's a copy available in some other place, at least one. So you can either do this or increase the number of copies as well. If you are saying
another use case is disaster recovery. If it's very critical, you can have a second cluster that should be using this volume replication class that Yati told, and you have a second cluster which, if my first cluster is down, you can still use your second cluster. Yeah. Any more questions? Yeah, sure. Mike.
Yeah, so on the OSD side, like in the replication mode, like 3 replicas are there. If one of the disk performance is getting degraded, okay, so what kind of impact does it bring to the cluster as well as on the user side?
Yeah, so in a Ceph cluster, your best performance is the best performance of the disk, the least performing disk. So you can get the metrics and see that the cluster is not performing, and try to diagnose which disk is actually not performing well using smart CTL metrics. There's monitoring, there's exporter for that as well. And if you have a disk going bad, of course you should replace it in the Ceph cluster.
So also is it depends on the OSD count also, like if I have large number of OSDs?
No, the OSD, you can add any number of OSDs. You can, Ceph is highly scalable, so you can add more nodes, you can add more disks, and it will scale very well. The only limitation would be, I'd say, the disk performance. If disk is going bad, replace it.
So it will cascade it to till the users.
So we have seen like clusters where people are running 1,000 OSDs per cluster. So it's that much scalable. So
it's like exabyte scale of data. It can scale very well to that level.
In that case, even if a single, even if one of the disk is degrading, means that would affect the performance of.
Can you please put
hello? Yeah. Even if one of the disk performance is affected, so it would impact the entire cluster performance. I'm just trying
to that won't be true because we have a primary OSD.
The replication would be
Yeah, whichever data is getting stored on this OSD. So if 3 replicas are happening somewhere and it is using this disk, in that case, that replication will get affected.
So we have a primary OSD concept. So when the data comes, it goes to the primary OSD and then replicates it. So if the primary OSD is near to your client, it won't be affected because the replication works behind the scenes. But if the primary OSD and you have the read affinity enabled, then there should be a problem.
Like only those placement groups which are in those OSDs, performance should be affected.
Yeah,
others are good.
Yep.
Yeah.
Okay.
Yeah.
So is this use case like, sorry, I come from a data distributed background actually. So is this can Rook and Ceph be used for like running basically say terabyte scale Fling pipelines? So currently the way the big data stack, the way it looks conventionally on cloud is you have an S3, basically use S3 Parquet files. On top of that you use Iceberg. Basically on top of that you basically have your Flink running, leveraging reading, writing, etc. Which Iceberg does a lot of things of course, but S3 with the basic storage of S3. So again, S3 has its own quirks. So just wanted to understand, has Rook and Ceph combination been used for such use cases? Like streaming applications and batch workloads, like basically where an Apache Spark cluster, I deploy an Apache Spark EKS cluster, I'm going to read data. Instead of doing it on S3, can I just move it to, block?
Yeah.
Ceph, which is, I believe, is a distributed file system, and can I basically just bring on the same functionality from S3 onto Ceph FS?
Yeah, that's possible. Like if you are asking about migration from one type of storage to another type of storage, That for that you need to do some manual works. But if you are talking about streamline things and the performance, so we have more users around the network industry. So that's, you can see like how the performance is for the Ceph.
Okay, so I think the TLDR would it be like, hey, okay, yes, Ceph and Rook can be used for big data systems as well. And
Yeah, that's mostly used currently in the industry.
Okay, thank you.
Last question. Hello. So there is another option for block storage, that is Longhorn. So have you done comparison in regards to performance?
Yes. So yeah, I have heard about this Longhorn and this KubeCon a lot. But the thing is like, yeah, the offering they are doing is same. But the scalability and the things that we get from Rook is, currently you want block storage right now, but what if in 5 years now you are requiring for S3? You need some migration to different tools for that. But here you are getting all three at the same time and with those scalability. So that's, I guess, the major factor among other features that we are getting from other tools. Yeah.
Okay. Have you done comparison in terms of?
Not specific benchmarking, but we have, yeah.
Sometimes back, someone from community did the benchmarking and shared in our Slack. I don't have that handy, but you can ping me on Slack or us in Slack. We can share that. So yeah, there was some benchmarking done.
Okay. Yep.
Thank you.
Yeah, for sure.
Sorry for asking too many questions, but yeah. So the point is, when you are allocating storage to Ceph, right, you have filters possibility where you define what this, your Ceph should take control of, right? And I believe you also have an option that in the host, we first create a kind of a local striping using LVols, and then I give a logical volume to Ceph. Is that possible, right? That I first, in a host, I have three disks inside a storage. I create a local stripe on it, and then I give a single stripe to storage per node. So, and the other ways, I don't create a stripe and let 3 OSDs run on that host, right? So there are two options. So what is the recommended way? Should we start creating stripes just to make more throughput out of a system? What are your suggestions?
So the best way is, and we are generalizing this now, so best way is to do the stripe, and for stripe we mean like Rados namespaces for block and sub-volume groups for file, because a cluster has limited PGs.
Yeah.
And to scale it, and if so that means we can have limited number of pools.
Yeah.
So that's why we should stripe in a real time because of that PG's limitation that we have.
Okay. Is there a documentation around it which gives you these best practices, what you should do with your local storages, how you should allocate that storage to Ceph? And
sure. So actually, with the examples.yaml, we actually try to give the best possible configurations that a user can have. But you can request for certain things. We can have like a certain kind of this. I guess this is a good feedback we can add.
Okay. Yeah. Maybe a best practice is coming out of here.
Sure.
We got this question many times, but it's very difficult to have a best practice because there's a network thing. There's a hardware thing, there's different use case.
Absolutely.
So it's very difficult to have a common best use case.
I understand, but for you to have some comparison, you just take a single node, right? Run 3 OSDs with 3 disks, and you just create a stripe and then do that benchmarking. Where are you getting more performance out of it?
Okay.
Whereas there's no network coming into picture. On a local storage, when you are writing to a local storage, what is the throughput you are getting when you have a stripe created versus 3 OSDs running on the local systems?
So how we do performance testing is we do FIO test on the disk directly, and then we use FIO with Ceph, and then we have the performance comparison, and also consider the 3-way replication into factor as well. If it's coming, I think, then depending on the disk, like SSDs, NVMe or HDD, compare the local disk performance and the Ceph's performance. That's how we do.
Yeah, and I was just more concerned about getting local performance out of the system,
Local performance, of course, you'll have some difference, but you have to consider 3-way replication.
Yeah, that I understand.
Yeah, but I think it's good enough. I can't say numbers because it depends on the workload as well as, and from my experience, if you're using SSDs or NVMEs, it's better to use them, and that's for the future as well. well. And I have seen decent performances. I can't give you numbers, but
thank
maybe
you.
offline.
Thanks a lot.
Yeah.
Any last words?
So, it's regarding the DR. Okay, disaster recording. So basically, on the ODF side, we have customers. They are asking for DR, but the issue here is like we have to set up the cluster. One is on the one region, another cluster we have to set up entirely. That is consuming resources as well as the cost. Is there any simplified way of like because I just want to deploy just only one OSD instead of the entire cluster, but that OSD won't serve
Then
to
how
any
will-
clients, something like that.
Then how will you ensure fault tolerance if that one OSD goes down? You can deploy
You
one
can have
OSD.
manual configuration for that using some manual operator that will migrate all your volumes to some standalone storage. But we can take this offline for sure and discuss more on this.
Yeah, definitely.
Yeah.
Because we are more concerned about the cost actually for the
Yeah,
customers.
so maybe erasure coding you can look into. We can discuss that more.
Any
as well.
last words?
I think somebody was there.
Hello, myself Bhautik. I worked with Longon around 3 years ago, and I am still using Longon. I have contributed in Longon as well. I want to basically understand consider I have 5 nodes in a cluster, dedicated 3 nodes for the storage, right? And my pod is scheduled on node which I am not setting basically for storage, right? Under the hood, Longon uses the OpenSCSI driver, right? So what are you guys using for the
CFFS,
CFFS and
CSI.
RBD for the
Block
block
storage.
I guess Longhorn is
RBD
for the
means
block storage.
Redos block device, and that's catering to the
And you
block
can
storage.
have dedicated storage nodes using trains and toleration. And the operator will be installed on those only.
Okay, so consider I've created the volume and my pod is scheduled on a particular node, right?
Yeah.
So basically, when the time of mounting in the Longon, it creates the basically client, right? And attached to the server, right?
Sure.
So how?
I got your point. So we actually give the PV to you, and PV is not namespace scope, and it's generally available. So you can just give the PV name to your pod application and use any namespace, any nodes storage using that PV.
So all of that is Ceph side is abstracted. When you like need a read write many, we'll just create a persistent volume for you or claim. You can just mount it, and in the background, Ceph will do his thing. You just have to mount it anywhere you want. So yeah, accessible.
Okay. And does S3 supports read write many?
It's a bucket object storage. So I mean, for read write many, file storage is better. If you are overriding it, then of course you can
It's natively
override.
how S3
works. Yeah.
Good.
So
Okay.
it's
Thank you.
object storage.
Yep. I guess we are good now. Okay.
Maybe our booth is also open till 5:14. So yeah, if you have more questions, you can drop by.
Yeah. Thank you so much, guys.
Thank you.